Lesson 3, Writing Equations to Model Relationships, Part 2. Learning target, when given a description of a situation, I can use representations like diagrams and tables to help make sense of the situation and write equations for it. In the previous lesson, we worked mostly with familiar relationships and reasoned repeatedly, which enabled us to see the relationships between two quantities. In this lesson, we'll be given tables of values and asked to generalize the relationships between pairs of quantities by studying the values and looking for patterns, and by interpreting them in context. Let's take a look at an example. A plane departed from New Orleans and is headed to San Diego. The table shows its distance from New Orleans, x, and its distance from San Diego, y, at some points along the way. What is the relationship between the two distances? Do you see any patterns in how each quantity is changing? Notice that every time the distance from New Orleans increases by some number of miles, the distance from San Diego decreases in the same number of miles. For example, 100 miles from New Orleans to 300 miles from New Orleans is an increase of 200 miles. 1,500 miles from San Diego to 1,300 miles from San Diego is a decrease of 200 miles. Notice also how the sum of the two values is always 1,600. For example, looking at the third row of the table, 500 miles plus 1,100 miles equals 1,600 miles. We can use this noticing to find the missing values on the table. The first missing value is 580 miles. This is because 580 plus 1,020 miles equals 1,600 miles. Subtracting 1,020 from 1,600 is one possible strategy to help us determine the missing value. Now it's your turn. If the place is 1,450 miles away from New Orleans, how many miles is it away from San Diego? The plane would be 150 miles from San Diego. We can represent the relationship of the plane's distance from New Orleans, x, and its distance from San Diego, y, with more than one equation. Earlier we noticed the sum of the two values is always 1,600 miles. Therefore, it makes sense to write the equation x plus y equals 1,600 to represent the given situation. We also found the miles from New Orleans, x, by subtracting the miles from San Diego, y, from 1,600. The equation x equals 1,600 minus y fits this description. Which equation would you use to determine the number of miles from San Diego? We can find the miles from San Diego, y, by subtracting the number of miles from New Orleans, x, from 1,600. Y equals 1,600 minus x fits this description. Now let's write an equation given a description of a situation. While we're not provided a diagram or a table of values, it may be helpful to create one to make sense of the situation. A student starts a new semester with $30 in their lunch account. Each lunch at school costs them $1.75. What is the relationship between the number of school lunches purchased, N, and the dollar amount in the account, A? To help us determine which equation represents this given situation, let's create a table of values. We know the student starts the new semester with $30 in their lunch account, which means they have not purchased any lunches yet. A school lunch costs $1.75. How much will be left in the account after the student purchases one lunch? After one lunch, the student will have $28.25 in their account. Let's take a look back at the given equations. Which can we eliminate so far? We can eliminate A. We're subtracting $1.75, not $30, from the account each time that the student purchases a lunch. We can also eliminate option C. Money is being taken out of the account instead of added to the account. By now you may recognize which equation represents the situation. Let's take a look at one more row in the table to justify our reasoning. The student will have $26.50 in their lunch account after purchasing 2 lunches. Option D matches the given situation. We can justify our reasoning in 2 ways. First, if we substitute the values 0, 1, and 2 respectively into the equation for option D, all of the outputs match with what is shown in the table. We are also subtracting $1.75 each time the student purchases a lunch. Option B is equivalent to A equals $28.25 times N, which does not match our given situation. For our last example, let's try to reason about the relationship between quantities in a new way. A company decides to donate a total of $50,000 to charitable organizations. Each selected organization will receive an equal amount of donation. What is the relationship between the number of selected organizations N and the dollar amount each will receive D? Let's consider the size of each donation for different numbers of organizations. If 5 organizations are selected, each one receives $10,000. If 10 organizations are selected, each one receives $5,000. If 20 organizations are selected, each one receives $2,500. Study the values carefully. Do you notice a pattern here? 10,000 is 50,000 divided by 5. 5,000 is 50,000 divided by 10. 2,500 is 50,000 divided by 20. Given this pattern, which equation represents the relationship? We can generalize that the amount each organization receives is 50,000 divided by the number of selected organizations, or D equals 50,000 divided by N. To summarize, there are a number of ways to reason about the relationship between quantities and write an equation to represent that relationship. Creating a table to help us see how a quantity changes or how two quantities might be related. Looking for a pattern in the table, noticing how the values in the table change from one row to the next, or from one column to the next. Trying different numbers for one variable and observing how they affect the other variables.